Now, in refraction of light through a prism, first of all, we have to understand what is prism. You know, in a prism, this way, it is three-dimensional. Okay, three-dimensional, and here is a rectangular surface. Okay, these are three rectangular surfaces and two triangular surfaces. So, in a plane, we show prism in this way. Okay, this face and this face are two refracting surfaces of the prism. This is the base of the prism, and this angle is known as refracting angle of the prism. So these are different parts of the prism. In a prism, there are three rectangular or square surfaces, two equilateral triangles are there, and these two refracting surfaces, these are two refracting surfaces. This is the base of the prism and this is the refracting angle of the prism. Now let us see how the light ray refract through a prism. Suppose this is equilateral prism. Equilateral prism means all these angles are equal and equal to 60 degree. Let this prism be A, B, C. This is the incident ray. Suppose PQ is the incident ray and this is the normal. Now the light ray travel from air to glass, so rarer to denser. So this light ray bend towards the normal. Now this refracted light ray is incident on the face AC of the prism. So this light ray refract and now it is moving from denser to rarer medium. So it is bending away from normal. Let this angle be I, angle of incidence. This angle be R1, angle of refraction through the surface AB. Let this angle be R2, it is angle of incidence through the surface on the surface AC, and let this angle is E, that is called angle of emergence. Now this is the incident ray and this is the emergent ray and this is the refracted ray. If the incident ray is produced forward and emergent ray is produced backward, then the angle is called angle of deviation delta. This angle is called angle of deviation delta. Now let us see how these I, R1, R2, E and delta are related. This is the normal. This is the normal. Now first let us consider these 2 points as T and this point as M. Now consider the quadrilateral AQN, say PQ, this is R suppose, and this is S. So let us consider the quadrilateral AQMR. Which quadrilateral? AQMR. In this quadrilateral, you can say angle A means this angle plus angle Q plus angle M plus angle R equal to 360 degree, because sum of the four angles of any quadrilateral is 360. Now angle Q and angle R both are 90 degree, therefore A plus 90 plus M plus 90 equal to 360 degree we get. So the result is A plus M equal to 180 degree. This is equation 1. Now let us consider this angle. What is this angle? This is the deviation, first angle of deviation, delta 1. And this is, if you consider this angle, this is the second angle of deviation or angle of deviation through the second surface, this is delta 2. So delta 1 is the deviation of the ray through the first surface AB of the prism. So you can see this is the actual light ray deviated through an angle delta 1. Now this is the actual light ray crossing deviating through an angle delta 2. So delta 1 is the deviation through the first surface and delta 2 is the deviation through the second surface. And why I am writing this angle and this angle equal? Because they are vertically opposite angle. Now in triangle TQR, what we can write? In triangle TQR, we can write exterior angle delta equal to sum of interior opposite angles delta 1 plus delta 2. So what is delta 1? This is say equation 2. You can see in this diagram that angle I equal to delta 1 plus R1 vertically opposite angle and angle E equal to delta 2 plus R2. Therefore, delta 1 equal to I minus R1 and delta 2 equal to E minus R2. Now let us substitute the value of delta 1 and delta 2 in equation 2. This 2 we substitute in this equation. So what we get? Delta equal to, in place of delta 1 I write I minus R1 and in place of delta 2 I write E minus R2. So delta equal to I plus E minus R1 plus R2. This is equation 3. Now let us see the triangle QMR. In triangle QMR, in this triangle you can say R1 plus R2 plus M is equal to 180 degree. R1 plus R2 plus M equal to 180 degree. So what is R1 plus R2? R1 plus R2, or let it be R1 plus R2 plus M equal to 180 degree. Let it be equation 4. Now we equate equation 1 and equation 4. From 1 and 4, what we get? From 1 and 4 we get A plus M equal to R1 plus R2 plus M. Cancel M. So A equal to R1 plus R2. Let this is equation 5. Now substitute the value of R1 plus R2 from equation 5 to equation 3. Substitute the value of R1 plus R2 from equation 5 to equation 3. What we get? Delta equal to I plus E minus A. So we are getting the relation A plus delta equal to I plus E. This is equation 6. So we are getting two very important equations of prism. This is equation 5 is one of the equation, that is A equal to R1 plus R2, and 6 is another equation which states that A plus delta equal to I plus E. Now on the basis of this calculation, we can understand what are the different factors on which the deviation produced by the prism depends. Now deviation or angle of deviation produced by the prism depends on various factors, and these factors are: first, angle of incidence. Angle of deviation depends on angle of incidence. Angle of deviation depends on the refractive index of the material of the prism. Refractive index of the material of the prism. Angle of deviation depends on angle of prism, and angle of deviation depends on wavelength lambda. Now this angle of deviation depends on angle of incidence, And as you change angle of incidence, angle of deviation will also change. First its value decreases, reaches to a minimum value, and then again increases.